Weinberg called it burning the rocks. You could literally mine rock just for its energy content.
Thorium is so common in the Earth's crust that an average American's yearly energy demand, including industry and transportation, could be met by a half barrel of everyday rock.
Dirt anywhere in the world worth many multiples of crude oil. But the key is to very efficiently convert thorium into energy.
Prosperity depends strongly on energy for cooling, for heating, water purification, sewage processing, medicine, communications, for industry. All those things depend upon electric power.
It's all well and good to just imagine everyone will stop driving their cars or traveling on jets.
I live fairly modestly. I drive an 18-year-old Saturn, but I'm still an American, so that means I use vast amounts of resources no matter how frugal I am.
Each year, the United States consumes almost 100 quadrillion British thermal units of energy. Per capita, that's the equivalent of burning 54 barrels of oil every year for every single American, or 12 tons of coal, or 5,300 cubic feet of natural gas to generate the same amount of energy. As you can probably imagine, the pollution released by harvesting, then combusting any one of these fossil fuel options is immense. Even natural gas, the cleanest of the three, releases substantial greenhouse gases.
Today's nuclear reactors run on uranium oxide solid fuel rods.
If we had more of today's reactors in operation, only 1 cup of uranium oxide would cover a typical American's yearly energy demand.
But this is thrown in our face, possibly for good reason, too. What I'm working on is the dream that failed.
Conventional nuclear power is essentially stagnated, particularly in the United States.
Nuclear innovation stopped in the 1970s.
There's another option, thorium, element 90 on the periodic table.
It would only take 4 grams of thorium to meet an American's energy needs for a full year. That's 4 grams.
Go out to Nevada and dig down about 12 feet, and in nice tractor-trailer containers, open the doors, and there's barrel after barrel of thorium nitrate, about 3,200 tons, which would provide about 2/3 of the planet's energy needs for a year.
Thorium would never need to be mined, ever, if you simply took monazite waste streams that could answer the entire Western world's rare earth crisis. You would stockpile enough thorium to run the entire world on thorium reactors.
The best way of getting thorium, frankly, is go down to the beach in Florida and just dig some sand.
Thorium could serve as an essentially unlimited nuclear fuel. You could catalyze the burning of thorium indefinitely.
The reactors we use today answer the question, how do we power a 1950s-era nuclear submarine? The USS Nautilus.
So we basically have this sub-design put into shipping port for the first power generator, and we built 400 of those.
The Navy program was optimized to the needs of the Navy. It actually wasn't very well optimized to the needs of power production.
We're extracting about 0.5% of the energy that's in the uranium. You can imagine going to your boss saying, I developed a new system. Well, how efficient is it? It's less than 1%. Excuse me, what did you build? I think you need to go work on that again. You know, I mean, we just simply wouldn't accept this. We could use thorium about 200 times more efficiently than we're using uranium now. This reduces the waste generated over uranium by factors of hundreds and by factors of millions over fossil fuels.
Even without disastrous side effects, we still have a finite source of fossil fuel materials.
We're quite sure we can make it cheaper than coal, but as long as you're close to coal, people are going to choose something over coal.
Coal is extremely plentiful in North America. OPEC is not going to jack up the cost of coal. Coal is cheap.
Coal causes 13,000 deaths a year. That's in the U.S. alone. In China, over 100,000.
We are the second largest economy in the world. How do we meet this gap? It's a huge challenge.
Energy and coal use is growing rapidly in all the developing countries, and they're being supported by Peabody Coal.
Rich countries can afford to overpay for things. We can afford to overpay for medicine, we can overpay for energy. In the world where most people live, 80%, energy is going to be bought where it's economic.
To you and me, national energy choices are the difference between cheap and expensive gasoline at the pump, the cost of heating our homes, and just another factor in how competitive our manufacturing sector can be. Outside of developed nations, energy is a difference between life and death.
They will use the cheapest, energy source available to them because they desperately need that electric power.
Germany's a first world nation, so why are they still building new coal plants?
The holy grail for renewables is to be able to store the electric power one day and use it the next. And it's very expensive.
Like fusion was so hard to do, storing energy cheaply has been a remarkably difficult challenge for 50 to 100 years.
All the types of batteries that get made for cars, for computers, for phones, for flashlights, for everything, all the batteries we make now could store less than 10 minutes of all the energy the world uses.
Thorium provides power when the sun goes down. Thorium provides power when the wind stops blowing. It doesn't depend on location. It doesn't require new transmission lines to be built from solar or wind farms to where the energy is actually needed.
And for the CO2 problem, so we have to go from rapidly rising to falling all the way to zero.
Power reactors don't contribute CO2 to the atmosphere. They should, by golly, be pursued. Period. And not to do it is sort of insane, really.
We didn't develop nuclear energy off the back of the moonshot. We developed nuclear energy off the back of the atomic bomb.
Now, I spent 10 years working at NASA. There's no coal on the moon. There's no petroleum. There's no wind either. The moon orbits the Earth once a month. For 2 weeks, the sun goes down and your solar panels don't make any energy. So nuclear energy was really the only choice. They had to come up with all kinds of new materials, new seals, new gaskets. There's an analogy here of taking the evolutionary steps and taking the revolutionary step. We will use
new metal alloys, some of which have not yet been invented.
Just like the moonshot, we can't anticipate what all the benefits will be. But we do have a baseline: clean, plentiful energy.
I'm a rocket engineer. I know how to do this stuff. Building a reactor is a lot easier than this.
Why climb the highest mountain? Why fly the Atlantic? Why does Rice play Texas? We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Mr. President, since you missed our meeting on breeder reactor, I am being ruthless on one thing.
Were either of you present when the reactor program was canceled in the early 70s?
Yeah, we were still working there.
Finalizing reports on the performance.
How do you feel about the reactor now?
Did exactly what we calculated it ought to do, and that's pretty satisfying.
Thorium was sidelined due to a range of factors, including political.
Any activities that we possibly can should be placed in Southern California.
It's very hard to see the green line for the molten salt reactor technology, and then ultimately it was canceled.
Put your hand on your desk, sweep it off onto the other side, and you're finished.
And became this interesting side note of history until fairly recently.
The very same day that we were at Oak Ridge talking about relationship between rare earths and thorium, Chinese Academy of Science made their announcement. We are going to do this. We're going to own the IP.
So we very much like to be energy independent.
Hey, maybe you shouldn't keep giving away this information.
If you want to do something about global warming, it would be a great thing if China built thorium-based reactors instead of coal plants.
There are currently about 300 people working full-time on it.
China is doing exactly what it needs to do for its people and to raise them out of poverty and give them a standard of living that they deserve, and their government should be congratulated for that.
The exploration of space will go ahead, whether we join in it or not.
The flip side of that is we're going to exchange Saudi Arabia for China.
A lot of the energy used here in China is not for consume, it's for production.
Our energy, no matter what, forever is going to cost more than their energy.
All we're consuming now is that very, very, very small sliver of natural uranium.
Uranium-235 is like silver and platinum. Can you imagine burning platinum for energy? And that's what we're doing with our nuclear energy sources today. We're burning this extremely rare stuff. And we're not burning the uranium-238 and the thorium.
So I have a friend who's trying to start a rare earth mine in Missouri.
Every known way to extract rare earths from their mineral concentrates, thorium just literally drops out like a rock and you have it.
How much thorium do you think you'll be pulling up a year? I think about 5,000 tons. 5,000 tons of thorium would supply the planet with all of its energy for a year.
The thorium is free, so it's going to be the most valuable commodity in the world with almost no value.
And he goes, and there's like a zillion other places on Earth that are just like my mine. It's a nice mine, but it's not unique. It's not like this is the one place on Earth where this is found.
Dig out rare earth metals to make your magnets for your wind turbines, you get a load of thorium.
Without heavy rare earths, you're really not in the business of technology.
When you use concentrated solar power, you use molten salts as the coolant. So there are synergies.
Every time mankind has been able to access a new source of energy, it has led to profound societal implications. Human beings have had slaves for thousands and thousands of years. And when we learned how to make carbon our slave instead of other human beings, we started to learn how to be able to be civilized people.
If you gave me only one wish, I can pick who's president, I can pick a vaccine, which is something I love, or having energy be a quarter as expensive and environmentally friendly, I'd pick the energy.
Thorium has 1,000,000 times the energy density of a carbon-hydrogen bond. What could that mean for human civilization going out thousands, tens of thousands of years into the future? Because we're not going to run out of this stuff. Once we've learned how to use it at this kind of efficiency, we will never run out. It is simply too common.